The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everybody. It is Wednesday and the 1st of July, I should say, and coming up on a holiday weekend. Today, Richard's going to be talking about stress, methylation, qEEG, and related topics. So we're going to get started. Don't need to introduce Richard. Everyone will be kept on mute, and then towards the end, if there's time, he'll unmute folks for Q&A. This is part one. I think we're going to do one part each week for the next couple of weeks, Richard, on Wednesday.
Well, I'm hoping we get to it in 2, but if not, 3 max.
Okay. Well, at least 2, so at least next Wednesday. And remember, and I'll send another reminder, there is no Lunch and Learn this Friday. It's a holiday. All right, Richard, have at it.
Oh, thank you. I first did this lecture at Life University, which is, if you don't know it, is like one of the main universities for chiropractic for a group there. And you know, they're very tuned into a lot of this stuff. Not all chiropractors are, but a significant portion, particularly functional chiropractic and chiropractic neurology, very tuned into this topic. It's very important for them, and neurofeedback is becoming very important to that community too. And so what you can see, I engaged in a little iconography here at the beginning. You can see an image of a snip. We'll get to that in a minute, which is a kind of a break in your DNA. And on the right is somebody with anxiety and depression, beta asymmetry and alpha asymmetry. And those are the substrate of what I'm about to discuss. I wanted to start off with just a little contextualizing of this presentation, though. And I'd like to reiterate themes that I reiterate all the time on Lunch and Learn, and so does Rob, and so does Martin, and even Judy, and a lot of the other people who chime in, and that although we move through this world as apparently separate entities or beings, that's an illusion from a scientific perspective. We're profoundly interconnected with our environment at both the physical and social level. More than half of our body, our organism, is made of other organisms like viruses, bacteria, and fungi. So we carry a lot of freight with us that's connected with the world in other ways. So the majority of these creatures evolved in parallel with us and communicate with the environment alongside of us. Some of them through our food, some of them through other physiological indicators that they monitor in us. Likewise, the majority of our social psychological self is derived from social interaction. So we pull from society the same way that we pull from the bank of organisms out there. And most of the building blocks of our self is derived and sustained by our culture, by its memes, by its ideas, by its politics, and through our interactions at work. And so we are intimately, deeply connected at every level, and we evolve through that interconnection. Even though we pull from these different sources, the genetic side of it does direct our physical process quite a bit, but not entirely. The concordance studies of the 20th century and everything done since then tells us that the social and physical environment activates genes that we carry through different dimensions. And part of this is through mitochondrial intervention, and part of it's through methylation. Methylation can modify the action of DNA without altering DNA. And I don't want to get into it any deeper because it's a real rabbit hole. It's like neuroscience. But today I want to talk about what we've learned from the scientific literature and the functional medicine docs about how genetics and nutrition influence and contribute to mental health and wellness, because we're all deeply involved in that in neurofeedback, and the field evolved out of psychology and counseling. In later lectures, I'll address the genetic process and how it's elicited and shaped and fed back through social interaction more. And I have done that at different meetings, but many of you are not familiar with this material I'm about to present, and it's not necessary for you to know it in any detail. If you're new, most of us in neurofeedback don't know this in detail. So some of us only have heard about it, or we barely know it at all. But this is my effort to bring it to your attention if you don't, and help enrich it if you do. And at some point, maybe you can enrich in me, like some of the functional medicine docs do, on how it contributes to mental health and wellness. Because this is an unseen factor. This is an unseen dimension that's impinging upon our clinical efforts to aid and assist our clients in mental health and wellness. And it's an unseen dimension that can undermine our efforts and send us running looking for better equipment or protocols when we should be maybe farming out some of this and getting help from others, asking for help from other professionals to improve our neurofeedback outcomes. We have the possibility, as a growing field, become, in a sense, the monitors and managers of wellness. And that's somewhat what's exciting the chiropractic community, but it's also exciting the counseling community, because counseling is about guidance and management. It's really about helping people coordinate. And that's why social work is so close to counseling, coordinating this stuff. So just as sexual abuse, as Rob's presented it on the Lunch and Learn and up on the videos, can interfere with mental health and wellness, and just as sleep, as Martin hammers at us constantly about, and can interfere with health and wellness, and all of those things can make a huge impact that we can't see. This thing, methylation and nutrition, is also the other unseen factor. And if we can't see what's interfering, how can we manage? How can we make our treatments effective and help people? So that's why I want to present it, just to make you aware of this, inform you to some degree of it, get you thinking about it and how it might be interfering with your neurofeedback, and who you might talk to help you in the system. But at the end of this lecture, I will provide things that you can legally and ethically discuss with your clients, and recommendations you can make, which are well known. The CDC makes them. People from all different practices and professional walks of life talk about them and recommend them. You can go to the health food store, and the people in the health food store are allowed to recommend them. You can't recommend them if you're a medical doctor and you've signed a contract with a hospital saying you won't do it because the insurance companies don't like it, or the pharmaceutical companies don't like it. Then you can't do it. Something that we don't realize a lot of times. The doctor's hands are often tied, but ours are not. So we can talk about this to a degree, as long as we don't say, "Hey, we're an expert, and we're gonna cure you." You can talk about this. The core feature of most mental disorder is anxiety, and often with the addition of depression. Anxiety or chronic or hyperarousal is also a key feature of the invasion of pathogens too. The body ramps up when it has to. And these states can initiate and perpetuate both aversive physiological activity as well as distort and reshape behavioral patterns. They can reshape our behavior, distort it. A nice person can suddenly become an irritated, mean, difficult person to deal with that nobody wants to have anything to do with. And so it's easy for people with poor health, or people who are getting much older, who are difficult to deal with, to become isolated. And this can shape their internal behavioral patterns too. And this degrades the quality of our social interaction, our access to resources, and our survival and vitality. So we need to know about these invisible things that are outside our professional training that impinge upon it and undermine it. And here it is. Methylation nutrition is our key ones. So let's just kind of get moving on those. What are genetic polymorphisms? Well, the nickname for them is SNPs. And the single nucleotide polymorphism, which is what everybody's talking about, result in a shortage of key methyl groups. These methyl groups are critical for enzyme production in the body. Methyl groups are compounds, and shortages of these methyl groups can significantly reduce the level and production and breakdown of key neurotransmitters and also of proteins in the body. Methyl groups in general are utilized extensively in the body for the transport of nutrients. Well, you got to have nutrients everywhere, particularly in the brain, for it to work right, or you get mental disorder. And there's an example of a methyl group. You can see a carbon linked to 3 hydrogens. A shortage of methyl groups results in reduction in metabolic functions. Again, where you're going to get the energy in your brain, the neurotransmitters, the protein. The body becomes more open to assaults and forms infectious diseases and toxins. So here's a list of what SNPs can contribute to significantly with respect to the disease process. And this is a long list, and a lot of them come into your office. ADD, ADHD, multiple sclerosis, Huntington's, Parkinson's, Alzheimer's, autism's, no doubt schizophrenia at times, thyroid, massive depression, or sleep problems, or anxiety disorder, cardiovascular, mast is the same thing. So these things, not all of them, but many of them come into your office and you don't know that there are SNPs that are causing the problem. So let's talk about this methylation process in more depth and how it works and how it affects us. I think the easiest way to think about it is that we need resources that our body can't make. Methionine is a key compound. It's a critical amino acid that we use for protein synthesis as human beings. We can't produce it. We have to get it from somewhere. Folate is the same way. And folate is called vitamin B9, and it's critical for neurotransmitter production. And you all know what that means. You've been around long enough to know that. Without that, ain't nothing going to work right in the brain. And here are the pathways. Now, these are somewhat arbitrary, but these are basically the pathways that produce these things. There's a general pathway for production of glutathione, which is a major antioxidant in our brain and in our body. It is the major one. And this pathway also produces all the compounds for protein synthesis and amino acid synthesis. On the folate side, this generates what we call the B4 cycle, which produces all our neurotransmitters. So we've got the methionine side based on dietary protein and the folate side. And so here's another way of looking at them. There's the methylation cycle, the folate cycle, and the BH4 cycle. And you can see the serotonin, dopamine, tryptophan, tyrosine, all are over here. See this little link here called MTHFR. Well, that's not only a link here, it's also a link with the methylation cycle of methionine. And you see B12 and B6 is constantly mentioned here. So that should start to alert you in themes of MTHFR, B6, B12, and neurotransmitter production. So where do we begin? This is so complicated that people who specialize in this just put massive maps all over the walls and sit and study them for hours trying to grasp the meaning of it. And you can find them on YouTube. There's a lot of really top people out there doing this work. So methionine goes through a transformational process to become homocysteine. And homocysteine is measured on your blood test, by the way, for good reasons. We'll talk about that in a minute. The sources of methionine in your diet are meat, chicken, dairy, nuts, and beans. Now, Barbara and I are going to do a one-day presentation on using food instead of supplements and all this other stuff to manage this. And you can certainly talk to your clients about food, which is why we want to do it. You know, you can share recipe and healthy food ideas. And it's actually even better than nutrition. Supplements are something we need when we get really extraordinarily depleted. Methionine gets converted to SAMe, and you take that for depression, yeah, because it helps regulate hormones. So methylation produces this compound SAMe, and then that gets produced another compound called SAW, and these are all acronyms for really long words that none of us want to learn or remember. And it also produces adenosine, which helps regulate sleep. So right there, if you can't methylate properly, your hormones are going to be dysregulated and you won't be sleeping well. And that's a problem. And we'll talk about that more eventually. And you can't produce homocysteine. Well, why is that a problem? Well, then you can't produce antioxidants and your body will become highly inflamed, because just being an organism produces oxidative stress. And the only way to resolve it is the organism has to constantly produce antioxidants. And the key one is glutathione. And if you can actually deplete yourself of glutathione by over-exercising, it's a risk for all of the Olympic athletes. They can develop physical health problems from depleting their antioxidant glutathione from overworking their body. Notice B6 is in here. Got to have B6 for that antioxidant. B12 is absolutely necessary for SAMe. And then everything gets cycled back into methionine again. So homocysteine gets reinvigorated through a process that takes B12 and this other methylation process that you get from folic acid folate. So let's look at that one. First, let's say, why do they measure homocysteine in your blood test? It's associated with inflammation. High homocysteine levels say you got high inflammation. That means you could have something wrong with your folate cycle, or you're not eating enough green leafy vegetables. American diet. Also related to heart attack and stroke. If homocysteine's a lot high, it's like having your triglycerides high, and the doctor goes, whoa, we got to do something. It's related to excess clotting, venous thrombosis. I can't even say that word. I never could. Plaque buildup on arterial walls. The reason why I can't say that word very well is because I had a speech impediment when I was a kid. I had to go to speech class for 3 years. So plaque buildup, that's related to hemoglobin A1C. What's that related to? How much sugar you intake. The more sugar and refined carbohydrates you take in, the higher your A1C, the stickier your plaque is, the more it sticks to your walls. And that's related to high blood pressure. And all of this can be a measure of stress. So stress can undermine all of this. So let's say you're not getting enough adenosine. You won't sleep well. That could be from stress. And then you're not sleeping well, you can't produce enough homocysteine. Let's say you're producing too much homocysteine, but you can't convert it to glutathione. That's a problem. And then it's creating this problem. So you see, it's kind of a demonic game of all in the house that Jack built. It's a little bit like learning statistics. Everything is so enmeshed, it's hard to make sense of it. So we make glutathione from homocysteine. It promotes detoxification. It helps your cells repair, which is very important because they're always degrading when you age. It boosts immune function, which is critical for your health. And B6 is a critical cofactor. If you don't get enough B6, you can't produce it. And you get pyrrolate, and we'll talk about that later. That makes you cranky and explosive and irritable. So let's talk about methionine and the folate cycle. Homocysteine is converted back to methionine. So it's a big circle. And then we have B12 and zinc as being critical cofactors for that. And some of us can't methylate B12. You know, you buy cheap vitamins, you get cyanocobalamin. That's a form of B12 that a large percentage of the American population can't process. You just pee it out. You have to have methylcobalamin, not cyano. You can tell if you got good vitamins because they have methylcobalamin in them, not cyano. The cheap ones have cyano. So look at your B12. The folate cycles generate something called 5-MTHF, and this is where it gets really demonically complicated. This is an active form of folic acid. Now, folic acid is very important to have for all of this process. The problem is, as I said, we can't methylate folic acid, so we need methylated folic acid. So MTHFR enzyme converts something called 5,10 methylene tetrahydrofolate, a form of folate, into 5-methyl tetrahydrofolate called 5-MTHF. Yes, you will have to watch this video more than once. B12 plus 5-MTHF plus methionine synthase are central to the conversion process of taking homocysteine and turning it back to methionine, so the whole cycle can start all over again. But we need to keep on taking protein to supplement it. This helps, though, reduce the buildup of homocysteine, which has all those negative consequences. So we're going through all these complicated cycles, and we need to feed the body properly. But there's some basics here. B6, B12, zinc, good sources of protein, lots of folate, green leafy vegetables. I have seen green leafy vegetables take a low power map and turn it into a high power map, or a normal power map. Critical, and sad. The standard American diet is highly diminished in this important thing. When birth control pills first came out, they used to deplete folic acid in the body. Without that, large swaths of the female population came depressed, so depressed that alarmed the medical community, and it forced the FDA to force the manufacturers of those compounds that prevented pregnancy to add folic acid to it. And then they realized, oh, wait a second, folic acid can't be methylated by somebody. And so they had problems for buildup of folic acid. So then they had a methylated folic acid, or folate. So you see how complicated this all gets. And you don't have to know it all, but it kind of gives you an idea of what's going on here. You can have an 5-MTHFR deficit or an MTHFR mutation, a SNP. And that can cause problems because it's very important for serotonin and melatonin production, keeping calm and getting sleep, right? It can also result in digestive issues, migraines, excessive nerve pain and neuropathy, depression and anxiety, and that's a theme through everything here, schizophrenia, bipolar disorder, and chronic fatigue syndrome. So it can aggravate all these conditions and even trigger them in some cases. This deficit, 25% of the Hispanic population experiences it, and 10 to 15% of the Caucasian population of this MTHFR mutation. It's in your genes. And again, I want to emphasize that methylation requires B vitamins. And here's a list of the key ones: B6, B9, and B12. And you can see they're all critical for the methylation cycle. So if you're missing it, it shows you the symptoms of B9 deficits: loss of appetite, weight loss, weakness, heart palpitations, behavioral disorders. Now, those are comorbid with a lot of other things, so that makes it very hard. Well, do I need it or not? Well, These are water-soluble vitamins, so you can take them and you just pee them out if you don't need them. The only thing you're wasting is a little bit of money, but it's insurance that you're getting enough. A simple formula that's inexpensive for B vitamins that are well methylated is, for example, is Jarrow, Jarro. It's called B Right formula. That's one I recommend to a lot of my clients because it's inexpensive and it's high quality. And Consumers Lab says, yeah, it's good. There's a lot of others though. And you can get all of these. So B12 deficiency in severe versions can cause obsessive symptoms, agitation, even psychosis. B12 deficits increase homocysteine. As we've shown, you can't process stuff. Back to methionine, it builds up, and it's correlated with Alzheimer's, and it's critical for myelination. If you want your dominant frequency to be good, your alpha to be at the right center of frequency, you need good myelination. B12, critical. So that brings us to the BH4 cycle. The BH4 cycle is where we build our neurotransmitters. And we generate serotonin, melatonin, dopamine, epinephrine, and norepinephrine through this cycle. We need folate to do it, and we can't have an MTHFR polymorphism, which a lot of us have. So we need supplementation or a diet that is adjusted. But it's a lot simpler than that. If you just eat a truckload of green leafy vegetables, it can't hurt you. Then the more you eat, the better. It enhances, many of them are prebiotic, some of them are probiotic, and they're very good for you. They help you produce neurotransmitters. Okay, and you can see this gets very complicated. So how does this production take place? Of course, I had to drill down. I was fascinated. Well, how does this work? Well, BH4 generates tyrosine and tryptophan. These are precursors to your major neurotransmitters, tyrosine and tryptophan. That's why if you want to supplement yourself and make sure you're getting enough neurotransmitters, nutritionists will say, well, let's give you a little tyrosine and tryptophan. You know, now some of it's not going to make it through your stomach, but some of it will, and it get through your to your brain and can help with conversion. A lot of serotonin is made in the gut, so that can be very valuable right there. A lot of dopamine is made in the brain, but some of it's made in other parts of the body like the gut as well. Tyrosine is converted to dopamine, and boy, do we need that. Because if we don't get it, we go looking for it in drugs. And we start getting hooked on drugs because we don't have enough of it. We have reward deficiency syndrome. Dopamine is converted to norepinephrine, and epinephrine, without those, you got no get up and go and no focus and no concentration. And tryptophan is converted to 5-HTP, which is another precursor you can take for serotonin deficits and the depression and lethargy that comes with it. And also for melatonin, which is a hormone that you desperately need for sleep. So in this BH4 cycle, you produce melatonin, which is a hormone you need for sleep, but you also produce adenosine in the other cycle, methionine cycle, which you need to get drowsy. So both melatonin and adenosine are critical for drowsiness and sleep. I didn't mention acetylcholine. There's an alternative pathway for that neurotransmitter, and that's a huge topic in itself. But 90% of our population, according to the CDC, is low in choline and acetylcholine. And that's important for the fatty acids that help produce white matter and conduction velocity in the brain and good processing and good dominant frequency. High choline deficits can generate chronic fatigue syndrome and fibromyalgia. So it's important to get enough choline. The choline cycle can compensate to some degree for the folate cycle, and it can convert homocysteine to methionine. So it's a backup system, but it's very inefficient, and it occurs primarily in the liver. And if you have any liver problems, well, then you're in deep trouble right there. Common symptoms of low acetylcholine are poor memory, poor focus, brain fog, and diffuse high alpha. And you've seen that on your map, right? So in relating to issues to methylation, we need to go back to the stages of oxidative stress. And if you haven't seen that video of mine, you should look at it or read about it. And it's the recognition that what we're seeing in brain maps is mostly the fundamental physiological response of the brain to oxidative stress. And there are many sources of that, both environmental and social. And there's a pattern to it. And when we see these different patterns in brain maps, we're seeing a progression of stages from health and wellness to deep oxidative distress and inflammation. And methylation can speed us along the negative version of this pathway from stage 1 to 8 in a rapid and unsatisfactory way. Now, in going through this process, we go through a stereotypical pattern of activity in a healthy body. And James Hobson and I, put this together and presented, I think, at 2016 ISNR. And wow, 8 years later, after 2008, like 40 people showed up for the workshop, and the CD outsold all other CDs because not everybody could make it. And we were like, wow, there's real interest here. But it was very heartwarming. People weren't just trying to buy better equipment and find magical protocols. They were actually looking at confounding factors, the efficacy of their neurofeedback. So these are the 3 stages we kind of put it in because it kind of correlates with a Hanselier, and here Martin talked about Hanselier all the time. And we have adrenal hyperactivation from stress, the alarm stage, and our body begins to resist that. Our alpha begins to decrease a little bit because we increase our beta activity, and our asymmetry starts to move to the right hemisphere. But it's a subtle shift, and it doesn't always show up on maps. Some people, it shows up more than others. During that process, we have a massive decrease in magnesium because the stress eats it up a lot, and decreases in sodium, increases in sodium, cortisol, increases in glucose because the body is alarmed and our body starts putting out more glucose to deal with it. It's the same reaction that we have to viruses and bacteria that are invading, but stress is an invasion in its own sense. And there's increasing acidosis in the body and in the gut, which shifts the microbiome. Then we move to a stage where we start to get tired, and we have reduced efficiency in adrenal output. It puts a burden on the liver and the thyroid, and it puts a burden on, our glucose production system. And a lot of people start to develop insulin resistance and have big sugar swings and irritability because their physiology can't cope with it. At this point, potassium's decreasing, glutamate is increasing because we're having trouble, not because we're not sleeping enough, getting rid of it and clearing the glutamate. Insulin and cortisol are decreasing, as I said. Blood sugar is decreasing. There's a shift in microbiome. And there are deficits in DHA, which is going to affect your memory and your testosterone levels and your libido. and B12 and B6 deficits along with folic acid deficits. And there's an increasing amount of inflammation. And this is when we start to experience depression. And alpha starts to increase because we have chronic anxiety. We're starting to experience mood shifts. Alpha's going to start to shift soon into the left hemisphere. We're becoming exhausted. And our beta is high at this point, but it's going to start dropping. At a certain point, it's going to look like it's in the normal range, but we have high alpha, but it's not. It's in normal range briefly on its way down because we're losing our ability to produce energy in the brain. We're tired. And we're struggling to keep our beta high frequency activity up. And then eventually the alpha slows and we have thyroid fatigue and exhaustion. And that's going to push us right into high levels of inflammation and delta in the brain. So we have high amplitude, low frequency alpha. Often it looks like theta in the brain map. And often it looks like fast dominant frequency in the brain map, red there. And eventually it shifts to high amplitude theta. And we'll eventually get reduced perfusion and we'll get real theta as areas go offline into hibernation in the cortex. We're experiencing low selenium, cortisol issues. ATP production is depleted, so our beta is tanking. We can't produce high frequency beta. And at that point you can't pay attention and you can't think very well. Ion pumps are compromised and inflammation's high. So we have this, because of all of these methylation problems, we're accumulating higher levels of oxidative stress and moving through these negative stages. So beta asymmetry is a primary indicator of anxiety, much more than beta magnitude. I've done modeling with N sizes of 6,000 from the database system at the clinical level and done regression modeling. And asymmetry is the only thing that comes out as a strong predictor and correlate when you look at the regression modeling. So look for beta asymmetry and alpha asymmetry, particularly beta asymmetry, as anxiety. Okay, so let's start talking about anxiety, qEEG, and physiology and how it relates to methylation and nutrition. Now, the correlation between anxiety and adrenal symptoms on just the CEC is quite high. CEC is very good at telling you, that you're anxious. And if you're quite high in anxiety, you probably have adrenal issues. And that often is as a consequence of a poor communication between the hypothalamic pituitary axis and your adrenals, not because your adrenals can't produce stuff, but because they're not getting the right messaging. And that will affect your testosterone and estrogen levels as well. So, as well as many other things, so beware. Here are the symptoms of excess adrenal activity. Increases aldosterone, which increases sodium levels. It's going to affect your blood pressure, but low aldosterone also makes you foggy-brained and affects balance. If you're older, you can fall down more and have trouble driving. Reduced magnesium and zinc. So I've got that. Don't forget about the magnesium zinc. It's always good. 90% of our population is low on it. I recommend getting it in the form of a suspended solution. You can put it in your juice or your shake or whatever. But excess adrenal activity is associated with anxiety, irritability, nervousness, increased blood sugar initially, increased blood pressure. That's why you should always take your blood pressure in the morning before coffee or eating or exercising. Otherwise, you'll get a completely false reading. And the only people who can really take blood pressure properly are experts in it, cardiology clinics and cardiology practices. Even some of them have difficulties, according to experts. Overproduction of corticosteroids leads to increased inflammation. That's elevated cortisol. Overproduction of testosterone. Cell membranes become excessively permeable. not good because then viral entities and bacteria invade more easily, so can toxins. It's harder to get nutrients because you're developing an inflammatory process in your body, but also it's interfering with cell membrane activity and increased acidosis. This is associated a lot with the methylation component of the cycle called adenosine. Adenosine problems can initiate anxiety problems as well as correlate with them. So they can both cause and be a proxy measure of them. And they can cause or be a proxy measure of sleep problems. And this is the problem. It can be either a cause or a proxy measure. Not everything's that way, but these compounds are. So SAMe is converted to SAW, and adenosine is a product of SAW. And it's exported to the plasma when mitochondria develop a low energy charge. When ATP drops down to ADP and AMP, which is a lower level of energy production, they have to be re-energized back into ATP. So this is an important part of the cycle. But a failure in the adenosine pathway, and you can have a genetic polymorphism for this, and if you're highly sensitive to caffeine, you probably do, that can create problems with sleep because it has an inhibitory effect on CNS. It's an anti-inflammatory. It can generate symptoms of anxiety when it's low. It's blocked by caffeine increasing alertness. So caffeine can produce alertness and or anxiety, but caffeine also increases dopamine and glutamate, which in turn block adenosine. So adenosine is supposed to tell you when you're getting sleepy, but caffeine, it's an agonist, so it blocks information to your receptors and says, oh, you're not getting sleepy, so you push yourself past it. You're doing that with coffee, you're finagling with the adenosine cycle, but you can do the same thing with a genetic SNP or problem. It can interfere with sleep. And blocking adenosine increases adrenal output. So if you're slamming down a pitcher of coffee every day, this is what it's doing. It's messing with your awareness that when you're getting sleepy, it's messing with your sleep cycle, with your circadian, ultradian cycles. It's messing with your microbiome and your entire methylation cycle. A little bit of coffee is a good thing. A lot of coffee is a bad thing. Again, we're back to moderation in all things. So with chronic anxiety is sleep disruption adenosine and homocysteine, and disruption sleep, increasing cortisol and insulin resistance. Anxiety, and it shows up in your map as a lot of beta asymmetry, a lot of times fast alpha, and that's why fast alpha is related to insulin sensitivity and adenosine issues, and that polymorphism. It does show up in beta, but usually the way it shows up in beta, and we didn't know this a long time ago until that groundbreaking research was done on EMG, electromyography, and qEEG, and that is a large percentage of our beta, above 21 hertz, is muscle tension. And when you see high beta like this and beta, that's a reflection of a jacked up body, of hypervigilance. And people from families of toxic stress are chronically hypervigilant, have chronically tense bodies, are exhausted, don't sleep well. So that can be a cause, and that can influence adenosine, and that would be related to this kind of map. Here's an example of beta asymmetry. You can see anxiety is high, but it's not as high as you would think. Well, because it's coming down. Why is anxiety coming down? Well, if you statistically analyze it, which I've done and I published and presented at meetings, you start to see depression coming up. Depression is end-stage anxiety. It's not some unique thing floating out there on its own. That was a concept developed by the drug companies and promoted to sell drugs. Not my opinion, it's documented, heavily documented, across disciplines and in the congressional record. So depression starts to calm down this anxiety. Your body's saying, hey, cool it. We're developing inflammation. We're going to reroute stuff. We're going to make it so you can't get out there and screw around so much because you're causing too much trouble, which means that you don't know how to interact properly socially, or you've encountered environmental toxins that are undermining your ability to interact socially. You can't get your needs met. You can't get the resources. You can't get the attention, the love, the support, and the food and supplies you need for vitality and thriving. And so we get insomnia is always at the top of the list in this crew, and headaches often, sleepiness, cardiovascular, hair thinning if we're starting to get into thyroid issues. Adrenals are coming up. These do not have a rigid presentation. People will present differentially high. Some people might be higher in hypothyroid or hyperthyroid or adrenals or even blood sugar. This mix and matches according to your genetic makeup. What's your genetic window of vulnerability? In psychology, that was known as the diathesis stress model of psychology. Stress elicits genetic weaknesses that are unique to us and causes unique metabolic responses that are reflective. And this is just part of that SNP concept here. It was just called a different name with a different consideration or mechanism of action in those days. So this chronic hyperarousal leads to excitotoxicity. Now, having a bad marriage, having a kid with autism, ADHD, or reactive attachment disorder can give you excitotoxicity. Growing up in a family where you didn't learn to develop trust and draw boundaries, and you create a living hell for you in your environment and your child and your spouse because you don't know how to do that properly, and you decided you don't need counseling and that woo-woo stuff because you can tough it through. You're going to be excitotoxic, and so is your family, whether you like it or not. It's like a virus. It doesn't care. That's how biology works. And you're going to generate too much glutamate. You're going to have higher blood pressure, be upset. It's going to mess with your whole hypothalamic pituitary axis. You're not going to sleep well. You won't clear that glutamate. You won't be able to turn it back to glutamine, which you have to do. It's going to kill off your astrocytes and supporting cells in your brain. You're going to become degraded in your function. You'll still, yes, be able to call yourself a man, but you technologically, physiologically, scientifically, you're a pretty degraded version of man. And then it causes neuronal damage. Okay, and how? Well, this glutamate binds to certain receptors that allows entry of calcium into your body. And we noted that calcium issues are a major problem when you're distressed. Earlier on, when we were talking about initial stress, and that gets into the cell and it starts to cause cellular death or apoptosis. And then that can get absorbed by the mitochondria trying to protect their environment. They absorb it and then they start to die off and degrade, and you can't produce ATP. You can't produce ATP. Oh, look, you can't control sodium and potassium pumps, which means that you can't produce electrical activity because they're dependent on sodium and potassium pumps. And so how are you going to produce high frequency beta activity in your brain to process information if you don't have the energy, the high amount of energy it requires to do that? Other mammals can't do it. They don't have the ability to recruit glycogen like we do and consume massive amounts of fat and sugar to produce cortical high frequency activity and make all these social decisions. They can't do it. And when we're compromised, we're back down there at their level. We're just the same. We can't function socially well. Okay, so This results in mitochondrial damage and loss of energy resources. I think we'll stop here. And when we start next time, we'll just review briefly. This is the excitotoxic model that's related to anxiety. I presented it many places. It's up there on the internet, many presentations. And we'll talk about overmethylators and then get into depression and undermethylators. So we're going to start talking about overmethylators and undermethylators. But we want to talk about this late stage anxiety as we transition to depression, because that's when we see evidence of overmethylators and their symptomology and their panicky behavior and the resistance to depression. So I'll make that a unique topic to start with. Okay, any quick questions or comments? I think we've got a couple of minutes.
Everybody unmuted?
Oh, I got to start unmuting people. Excuse me.
So I know Vic, I saw you emailed.
I just undid Vic.
Okay.
I got Rick Millis is here just in case our.
Hi.
I'm here. I'm
Yeah,
here.
Dr. Suter, that was great. Thank you very much.
I loved it.
Thank you.
Good to hear you and see you, Rick.
He's our professor emeritus of physiology, so he actually knows more about a lot of stuff.
The only thing you left out that I was waiting to hear, and I know it was just an oversight, because you know what I'm talking about. Adrenal. When you start talking about adrenal activation, you can't leave out vitamin C. Vitamin C, very important. All the reactions in the adrenal gland to make cortisol and all the adrenal hormones are dependent upon vitamin C.
Wow, thank you. See, that's why we need you, Rick. Okay.
Yeah, you got it. You got to look at that vitamin C. And there's a lot of recent studies that show that vitamin C improves mood and does a lot of really good things. So, for example, oxidative stress that you talked about, that's the major killer in COVID. COVID killing is by oxidative stress. And there's actually a clinical trial going on now where they're giving vitamin C intravenously.
Really?
I think it's in China. They're giving a very high doses of vitamin C intravenously, and it's working against COVID.
Really?
Rick,
yeah,
Martin
so
here.
Fascinating.
Am I right that vitamin C, like vitamin B12, are two vitamins which the human anatomy cannot self-produce? We need to get it in through food, right?
That's correct. They're essential. They're essential. But the point, yes, absolutely. But the point is that vitamin C, as part of Hans Selye's hypothesis called the general adaptation syndrome in the adrenal gland, is highly dependent upon vitamin C as a cofactor.
At what dosage, Rick? What's the dosage you recommend on vitamin C daily?
Oh, as much as a person can tolerate. The problem is that you take too much and you get a little diarrhea. But 2, 3, 4 grams. I mean, you can't take too much vitamin C because, as Richard said, you'll urinate it out if you don't use it. But
right.
I mean, I would start with 2 to 4 grams a day if a person can tolerate it.
Okay.
Okay.
I know that I use it every 6 or 8 hours because it really runs through your body fast.
Yeah.
Pauling
exactly.
Pauling is the one who discovered or isolated.
Pauling. Yes,
yeah.
Pauling.
Okay.
Of course, a lot of work.
Yeah. He recommends 25 milligrams per pound body weight. So that adds up to what you said, Rick. Depending on your weight, between 3 for an adult, 3 to 5 grams per day.
Oh, good. Wonderful. Good. Thank you, Martin. That's great.
And Vic had a question.
You have to include vitamin C in the presentation.
Hang on for a second, Vic.
So, okay.
Okay.
Go ahead, Vic.
I don't have good reception here. Can you hear me okay?
Yes.
Yes.
So just following on from what you said, right? Thiamine, where I work in the hospital, the most common condition, of course, what it's related to our social cultural problems. People come in intoxicated, and we have a neurologist. The only thing he orders is IV thiamine. That's all he does.
Wow.
Virtually, I'm exaggerating, but 90% of his prescriptions, the nursing staff know, is the thiamine IV. You see, the other issue that was on my mind when you were talking was that so many of our pediatricians still are prescribed attention problems. So that, I think, teaches the brain to short circuit its natural cycle of building up the antioxidants and dealing with the oxidative stress, like you said. So yeah, I don't know if you have any words of wisdom of helping people decrease their dependence on the stimulant. When it first came out, everybody in the addiction world said those people who really need it won't turn to street drug stimulants, but that's not the case. I mean, I just see so many people using
well, sleep, diet, and exercise are really the keys to this.
Right.
That they raise testosterone levels, they increase production of dopamine, and as anybody who takes cat naps know, it's better to take a cat nap in the afternoon for 10 or 20 minutes than to have caffeine, or it's better to exercise. I like to do both, and boy, when you come back, you are way more focused and better than if you had caffeine. There's lots of alternatives.
Right. The Italians got that right with their siesta, right?
Yes, but also exercise really increases your ability to focus. And when I went to public school systems in the 50s and 60s, diet and gym class were really big components of being there. They aren't anymore.
Right. I mean, I see so many people, like, I started getting into triathlons, and then you get people who go to the other extreme. Like you said, too much exercise is not good either. Once you start getting competitive, then you drain the system too. So I think Hans Selye's model of trying to define euthymia, eustress at least.
Yes.
If you can optimize your eustress, then you can stay in a euthymic state that is optimizing all around. So that old word is really
it's called making lemons out of lemonade in my part of the country.
That's right. That's right. That's all I have to say. Okay, thank you.
Thank you. Anybody else before we call it a day?
Can you just say again, what's a SNP? What's a good definition of a SNP?
I've said it. Does anybody else have that might say it in a different way? Sometimes if somebody says in a different way, it makes more sense. No,
well, it's a single nucleotide polymorphism, which means it's a form of a gene. So we all have the same genes. All of us, all humans have the same genes, but we inherit. You can look at it as a small mutation. A very small change in the sequence creates a gene that does the same thing, but may not do it as well, or may do it better than somebody else. So, for example, if you have a gene for making endorphins, let's say we have an endorphin gene. Well, we do in our brain. It makes endorphins. So we all make endorphins. But the single nucleotide polymorphism that I have may create a lower level of endorphins in my brain than somebody else. And somebody else has a higher level. That could affect their pain threshold, for example. So I, with a polymorphism and a lower...
And we'll work on it.
So I have a SNP that produces less endorphins in my brain than somebody else. I have a lower pain threshold. Does that help?
Yeah, I was just wondering how that was related to diet, though. The whole topic of this presentation.
Well, these SNPs are ways we turn on genes and turn off genes. So it's called epigenetics. And so we have environment-gene interaction. The environment is our nutrition. So what you take in, for example, if you take in a high-fat diet, it may affect how much methylation is going on in the DNA. Methylation is a way that the DNA gets silenced to, let's say, repress the expression of a gene. So if that's my endorphin gene, if it's highly methylated because of my nutrition, let's say I can have a nutritional status that allows my genes to be hypermethylated, or at least this gene, then that could reduce my the amount of endorphins I'm making.
Okay,
and affect
thank
my
you. That
pain
makes sense.
threshold and affect my mood.
That makes sense. Thank you.
That's great. Good question. I'm glad you reiterated. Rick, thanks so much for weighing in. It's your expertise. You've taught.
Isn't that what?
So
Isn't that what you guys? Isn't that what you guys pay me for? Come on.
We're lucky to have you every once in a while, and this was a good moment. So thank you.
Yeah,
Well,
Rick, anytime you want to do an update on nutrition, please, or physiology or anything, if you have some interesting, let me know. Email me. This is Rob. Email me. We'll set up a date and time for you. We'd love to have you back.
Okay, good, good. I enjoyed it very much. I'll be back. Don't worry. Perfect.
All right, everybody.
Yep. Great. We're at the top of the hour now. That was great. Ran a little over, but it was worth it to get another version from an expert on the topic, and hopefully that helped clarify what we're talking about. So we'll pick it up again probably next week and do the second half, talk about it some more, and we'll be sure to add the vitamin C component in as per Rick.
All right.
All right. Have a great week, everybody, and enjoy the 4th, because we won't be meeting on Friday. We're giving everybody at New Mind the day off, as I mentioned last Neuro at Night, because we're trying to give up our Ebenezer Scrooge game plan here at New Mind and give people the day.
You all work hard. You all work hard.
Thanks,
You
Dr.
deserve the day off. So.
And we appreciate all of
it. We'll see you all next Monday night.
Yep.
Next Monday. Have a great weekend, everybody. Thanks again.
Bye.
Richard, great presentation.
Thank you.
Happy Independence Day.
Yeah, really. Let's keep it.
Happy Canada Day.
That too.
Yes, right.
Sleep tight.
We are 3 days ahead of the US people.
Yes, we are. Oh.
Yeah, we have a lot of virus down here. We're running a bit slow.
Adios.